Hi everyone, welcome to today's session on class 11 mathematics. That's trigonometric functions. So in trigonometric functions, today we'll look at the graphs for the trigonometric functions. So in this session, our learning objective is like by the end of this session, we will be able to draw the graphs for all the six trigonometric functions and also understand the domain and range for these trigonometric ratios, right? And also we will be able to draw graphs for a different amplitudes, right? So we will learn how to do that. So let's get started here. So the domain and range. So what is the domain and range? So the six trigonometric ratios, right? So we have sine x and cos x. So let's first look at sine x and cos x here. So if you look at sin x and cos x in the diagram here in the fourth quadrant, the unit circle, which is what we are taking as the base to learn our trigonometric functions, right? So here, if you see in the first quadrant, the value is between 0 and 1, right? The sin x or cos x value is moving from 0 to 1 or 1 to 0, right? And if you look at the second quadrant, it is from 1 to -1 or 0 to -1. And similarly, in the third quadrant, it is from -1 to -1 or 0 to 0 or 0 to -1. Similarly, in the fourth quadrant, it is moving from -1 to 0. So what we can observe is the range. The range for these is between -1 and 1, which is inclusive. You understood, right? So the values for these trigonometric ratios is in between -1 and 1. That is for sin x. Similarly, the same range applies for the cos x as well. So this is between -1 and 1. So that's the range. What is the domain? So domain can be any rational number, right? So any real number actually. So domain can be anything from the real numbers. Okay, so this is the domain and range for the trigonometric ratios. All right, so now we can do for tan x, right? So we can do for tan x as well. So tan x, cot x, and similarly cosecant x and secant x. So what is the range of tan x? Guys, if you remember the trigonometric table, right? So what is tan 0? Tan 0 is sine 0 by cos 0, which is 0. So it is from 0 to tan 90 is infinity, right? Tan 90 is 1 by 0, which is infinity. And on the other side, it can be, so the values can be minus values as well, right? So what is happening is this can be from minus infinity to plus infinity, right? Similarly, cot x is also from minus infinity to plus infinity. And domain can be any real number. Similarly, what is cosecant x? Cosecant x is a value which is always greater than 1. So uh, it can be the values other than -1 and 1 outside. That means it can be from minus infinity to -1 and 1 to infinity. So we will not get the values between 0 and 1 because the cosecant x is the reciprocal of sin x. So if sin x is between minus and 1, then cosecant x should be outside of it. Similarly, secant x can also be minus infinity to -1 and 1 to infinity. You're following, right, guys? So sin x cos x lies between -1 and 1, but cosecant x and secant x is outside of -1 and 1. So it can be any value minus infinity to plus infinity other than -1 and 1, the between values of -1 and 1. So these are the ranges and the domain can be any real number. All right, guys. So now let's look at the various values, right? the trigonometric ratios for various values. This I think we have already learned in previous classes. So sine 0 is a 0 here, and sine pi by 6 is nothing but 30 degrees, guys. Okay, we are writing this in radians now. So this is 45, pi by 4 means. Pi by 3 is 60, and pi by 2 is 90, and pi is 180, and 3 pi by 2 is 270. And 2 pi is, of course, we know that is 360 degrees. So the sine values for different different angles. So this we learn, right? Sine 0 is 0, sine 30, which is sine pi by 6 is 1 by 2, sine pi by 4 is 1 by root 2, and sine pi by 3 is root 3 by 2, and sine pi by 2 is 1, right? Similarly, cos is the reciprocal. These are complementary angles, so the reverse of it. Now we got that, right? Sine and cos, and then tan we can get by dividing sine and cos. So 0 by 1 is 0, 1 by 2 by root 3 by 2 is 1 by root 3, and so on, right? So if we look at cot, if we want to know what are the values for cot, so cot is what? Reciprocal of tan. 1 by tan means it's not defined. It's infinity or not defined, right? It is not defined. I'm just trying to extend this table, guys, for the remaining three trigonometric ratios. So what will be cot 30? It is 1 by root 3. The reciprocal of 1 by root 3 is root 3, guys. And similarly, tan 45 is the same value, right? So this is root 3, this is 1, and this is 1 by root 3. This is 1 by not defined is 0. This is not defined, right? And then this is 0, this is not defined. And similarly, what is cosec? Cosec theta. And also let's cover for secant as well. I'm drawing with free hand, so you may not get the perfect straight lines. So cosecant. So cosecant is what, guys? 1 by sine. 1 by 0. 1 by 0 is not defined, right? And then what is 1 by 1 by 2, which is 2. Then 1 by 1 by root 2 is root 2. And root 3 by 2, the reciprocal is 2 by root 3. If you look at the values, we are getting all the values greater than 1. And sine 90 is, cosecant 90 is also 1. So 80 is again not defined, 1 by 0, right? So it's not defined. And then what is 3 pi by 2 is minus 1, and this is also not defined. 2 pi is also not defined. So 0, 180, and 360, or 0, pi, and 2 pi are not defined for cosec. How about secant? Secant is reciprocal of cos. So 1, 2 by root 3, and root 2, 2, and then 1 by 0. Here it is not defined, guys. So pi by 2 is not defined, and then this is minus 1, and 3 pi by 2 is not defined. So here 90 is not defined, and then 90 plus 180, that is 270, is not defined. And this is 1, guys. All right. So these are the trigonometric values, the trigonometric sine values for different angles. Now, this is what the range we discussed, right? So sine is between 1 and minus 1 and 1. That's what we saw, right? So sine is between minus 1 and 1. That's the range. And cos is also minus 1 and 1. And tan is from infinity to infinity, right? And cot is also from infinity to infinity. And cosecant is infinity to 1 and 1 to, right, guys? Similarly, this is infinity to 1 and 1 to infinity, but not the values between minus 1 and 1. All right. So now, if you look at how these trigonometric values, the sine cos values, varies in each quadrant in a quadratic plane. So let's look at these guys, that same quadratic plane with unit circle whose origin is O, and this is X, this is Y, and this is minus X, and this is minus Y. So here the point is 1, comma 0. and here 0, comma 1. This is first quadrant. And this is second quadrant. Here the value is -1, comma 0. And here 0, comma -1. So this is the third quadrant and this is the fourth quadrant. Now, first quadrant, let's first observe what happens to the sine angle, right? What happens to the sine value? The sine value for sine 0, right? Sine 0 means it is at point. Let's say if this is A and this is B, and this is C, and this is D. So for if sine 0, that means the y quadrant is 0 here, right? In the first quadrant. And then sine 90, right? Pi by 2. So let's write the angles also. 0, 90 degrees, 180, and 270. This is 0 or 360. Or we can write as this is pi by 2, this is pi, this is pi by 2, and this is 2 pi. Now sine value, what is happening to the sine value? Sine value is nothing but the y coordinate, right? So it is increasing in the first quadrant from 0 till 1. That's what it states. See, it is increasing from 0 to 1. And similarly, what happens in the second quadrant? The y coordinate decreases from 0 to 1. Right, guys? And then what happens in the third quadrant? Y quadrant is it is decreasing from 0 to -1, negative value. -1 is less than 0, guys. So that's why we call it as right? And then what happens here? -1 to 1, -1 to 0. So in the first and second quadrant, sine is a positive value, which is between 1 and 0. And in the third and fourth quadrant, it is between 0 and -1. Okay. Similarly, cos is reverse. Cos is x coordinate. So it is 1 at 0 degrees and at 90 at pi by 2, it is 0. So it is decreasing from 1 to 0 in the first quadrant. And similarly, from here, it is increasing from 0. Oh, no, it's -1, right? In the second quadrant. So we still say this is decreasing from 0 to -1. And then in the third quadrant, what happens? The x coordinate is increasing from -1 to, right? And then it increases in the fourth quadrant, well, saying 0 to 1. Right? Similarly, tan. Tan, what happens to tan? Tan 90 is what, guys? Not defined. That's infinity, right? So it is tan. What is tan 0 is 0. So it is increasing from 0 to infinity in the first quadrant and increasing from -infinity to 0 in second quadrant. And similarly, increases from 0 to infinity quadrant and increases -infinity to 0 in fourth quadrant. Right, guys? So that's why I said the tan value, change of tan ratio from minus in, and similarly cot is reciprocal. So if tan is increasing, then similarly, so secant and cosecant, what happens, guys, is what is secant 0? Secant 0 is 1. So increases from 1 to infinity. So the secant and cosecant will not have the values between -1 and 1. Is from 1 to infinity or -infinity to -1 or -1 to -infinity like that. But it will not be the values between -1 and 1 for both cosecant. These are the ranges for the 6 trigonometric ratios. Now let's look at the actual graphs, right? So the first one, let's draw the sin x graph. So far we know the trigonometric angles and the values, right? So let's draw a graph now. So let's take a 0 degree and pi by 2, which is 90 degrees, and then pi, which is 180 degrees, and then 3 pi by 2, that is 270 degrees, and 2 pi. Let's write the values of this. What is sine 0, guys? Sine 0 is 0. What is sine pi by 2? That's the y coordinate, right? That's the y coordinate at the top, in the first quadrant. So sine 90 is 1. And what is sine 180? That means the half semicircle. That is 0, guys. Right? There is no y coordinate there. And then what is 3 pi by 2? 3 pi by 2 is, it's a minus value. So it is -1. And what is 2 pi? 2 pi is again 0, which is 0. So this is the value of sine angle. So let's draw the graph for these points, right? At 0, this is 0. And at pi by 2, it is 1. And at pi, it is 0. And at 3 pi by 2, it is -1, guys. And then at 2 pi, it is 0. So if I combine these points, I'll get a graph something like this. This is a sine curve. You understood? It is like an slipping S. And then the other side. So now I draw in the first and third quadrant. Now let's draw in the second and third quadrant, which is negative values. So we know, right, guys? Sine of minus x is minus sine x. We learned this, right, in earlier sessions. So now let's draw for 0 and minus pi by 2, then minus pi, and then minus 3 pi by 2 and minus. So these minus values are the rotation we are measuring in the clockwise, guys, right? So 0 is 0. There's no y coordinate there. And minus 90 means that is somewhere in the fourth quadrant, right? So minus 90 value is -1. Or so what is sine 90 value is 1. So this minus, you need to multiply with minus. So it is -1. Now pi is 0, right, guys? And then 3 pi by 2 is 1, and then 0. So let's draw this. At 0, it is 0, okay? At pi by 2, it is -1, right? And pi, it is 0. And at 3 pi by 2, at minus 3 pi by 2, it is 1, guys. And then at 2 pi, it is again 0. So if I combine this, it will come like this, guys. Oh, this is the sin x graph. So how we got? We just took the values from minus 2 pi to 2 pi. Here, guys, here, the domain we took, is from minus 2 pi to 2 pi. This is the domain. And the range we took here, the range is, what is the range, guys? It is the vertical portion. So the range is between 1 and -1. So -1 comma 1. That's the sin x graph. So I also have a textbook version of the sin x curve, how it reflects. So let's see here. So you see at the bottom, if y equal to sin x is the function, then the graph you will get is like this. I draw between minus 2 pi and 2 pi, but the graph here is, the domain here is -4 pi to 4 pi. Understood, guys? So this is how we can draw sin x graph. So in the board exams, if you get draw the sin x graph, this is how you can do. You take the various angles. You can draw between minus 2 pi and 2 pi and write the values for various angles and then just combine those. So this is how we'll get the sin x curve. All right. Now let's move to the cos x. So the same thing, guys. So let's take the values for 0, pi by 2, pi, 3 pi by 2, and 2 pi. So what is cos 0, guys? Cos 0 is 1. And cos 90, which is pi by 2. Cos 90 is what, guys? It's the x quadrant, right? So 90 degrees means it is 0. It's a point on the y-axis where x coordinate is 0. And then what is pi, guys? Cos 180, right? Cos pi. Cos pi is again x quadrant, that is -1, guys. And then 3 pi by 2, which is 270 degrees, that is again 0, guys. There is no x coordinate. Then 2 pi. 2 pi is again nothing but 0, which is 1. Right? Now let's draw the graph for this. So 0 is what, guys? 1. So 0 degrees is 1, guys. And what is pi by 2? Pi by 2 is 0 here. Okay. And pi is what? -1. Okay. And then 3 pi by 2 is 0. Okay. And then 2 pi is again 1. So how this is coming is So this is coming in this is similar to the sine curve, but at 0, it is 1. You understood? Now, let's look at for the negative values. So minus pi by 2, pi, 3 pi by 2, and pi. We already know, guys. So cos of minus x is cos x, right? So what is cos 0? Cos 0 is 1. And then cos pi by 2. So we'll get the same values. So we'll get the same values. It is 0 and pi is minus 1, 0, 1. So 0 is 1 and pi by 2 is 0. And then pi is pi is minus 1. 3 pi by 2 is 0. Pi is 1. So if I can combine this, it's exactly same as the sine curve. Sine curve passes through the origin, but here it does not pass through the origin. So this is here also, guys, same thing. What is the domain here? So the domain we have taken between minus 2 pi and 2 pi. And what is the range? Yeah, for cos x also, the range is between minus 1 comma 1. This is how we can draw the graph for cos x. And now let's look right? So this is the cos x curve. But bottom you see here, right? So y equal to cos x. So it is not passing through the origin, but it is with 1 and minus. Understood? So that's this is the cos x. In the board exams, you just these two tables and take indicates y-axis indicates 1, 2, 3, 4. It's 1. The x-axis indicates the angles in range. 0, pi by 2, pi, pi by 2, 2 pi. And on the minus x side, negative. So this is the graph for cos x. Now let's move to tan x. The same thing, guys, here also. Let's take the values 0, pi by 2, and then pi, 3 pi by 2, and 2 pi, guys. So what is tan 0? Tan 0 is sin x by cos x. So what is sin 0? 0. So 0 by 1. That means this. What is sin 90, guys? Sin 90 is not defined. That means it's a. And then what is tan pi, right? So what is the sin pi? Sin pi is again 0, right, guys? Sin pi is 0. So 0 by anything is 0. And then 3 pi by 2 in infinity, pi is again 0. So this is an interesting graph and listen. So tan x is passing through the origin. For 0 is 0. And for pi by 2 is infinity, guys. Infinity means somewhere here. So for pi by 2, it is like infinity. So what I can do is I can draw. Understood? And then for pi, it is 0, right? And for 3 pi by 2, it is again infinity. So yeah, maybe we'll get we had uh, values, right? So yeah, let's look at this table. So what happens in second quadrant? Oh, yeah. And the second quadrant, it is minus infinity to 0. And in the third quadrant, it is 0 to infinity. Okay. And uh, in the fourth quadrant, it is minus infinity to 0. Similarly, let's take the value. I also have plus 3 pi by 2, pi and minus 2. Yeah, let's look at the graph. if you see here, right? If you see here, what is happening is, correct? And what is 2 pi value? Yeah, here we need to see. So 3 pi by 2, I draw, that is at infinity. And then for 2 pi, it is 0, right? So 2 pi, for between 3 pi by 2 and 2 pi, the angle is where, guys? In the fourth quadrant. Fourth quadrant, what happens is, it is from minus infinity. Similarly, here, right? So here, it is from minus infinity. So how this graph is coming? Same thing here. Like what is tan 0, guys? Tan 0 is 0. Minus pi by 2 is minus infinity. Following? And then for minus pi, right? For minus pi, it is again 0. And for minus 3 pi by 2, minus 3 pi by 2, it will be minus infinity. And for 2 pi, it is 0. So here, if I look at here, then for pi by 2, it is from right, tan minus 90 degrees. And then similarly, at minus pi by 2, it can be a positive value as well if it is in second quadrant. So like this. So it will be, and this is from infinity to 0, right? So this is the tan x curve, guys. So tan x curve, what is happening is in the tan x side is from infinity. It can be plus infinity to minus infinity. So it is like uh, what is that? I can't tell you the exact shape, but yeah, this is how it's like an elongated S which passes through origin at 0 and pi and 2 pi. Okay, so this is tan x curve, guys. Now let's look at cot x curve, right? So same thing, 0, pi by 2, and then pi, 3 pi by 2, and 2 pi. Now, what is cot 0, guys? It's reciprocal to tan. So here it is, and pi by 2 is 1, and here it is again infinity, and this is 1, 3 pi by 2. So what is 3 pi by 2? We can check here. Pi by 2 is 1 or 0, guys. Hold on. Yeah, this is 0, right? Not defined. 1 by not defined is 0. And this is again 0. And then what is 2 pi? 2 pi is again infinity, right? Similarly, let's look at the minus values also, where we can get an idea how this to be. And minus 2 pi. What is cot 0? Cot 0 is 0. Cot minus pi by 2. Minus pi by 2 is the angle in the fourth quadrant. So what is cot minus pi by 2? Cot value in fourth quadrant is sine by cos. What is the sine value? Sine value is negative. Cos value is positive. That means we get a negative value. So that means it is minus. And then pi, minus pi. That's a value in the third quadrant, right? So in the third quadrant, both are negative. So we should get a positive value. So that is, hold on, this is infinite. Right? What is cot 0? Cot 0 is infinite. Cot 0 is infinite. And then cot minus 90. Cot minus 90 is angle in the clockwise. So which is the in the fourth quadrant. In the fourth quadrant, it is a negative value. So even though if it is a negative value, 0 is a 0, right? And then minus 180. Minus 180 is an angle in the third quadrant. So in the third quadrant, both values, sine and cos, both are negative. So what you will get? You get a positive value here. So it is, and then here you will get 0, and this is also it. So let's look at let's look at the graph should be same here. to the tan, but the only thing is for tan, it is passing through origin, but here at origin it is infinity. So origin is infinity, and at pi by 2, it is uh, passing through the axis. That means it should be something like this. Something. It should be opposite side to the x curve. You following? And similarly, at pi, it is again infinity. So it will be like infinity, 0, and here 2 pi is infinity. Following? Now, similarly, for the minus angles, so for the minus angles also, it is from 0 to minus infinity. So it will be like it's from minus infinity to 0. Here at minus pi, again it is infinity. And same to the, it's similar to the tan x curve, but in the opposite way. Minus pi, it is from minus. Okay, let's look at the curve. You see now, right? This is how the, so what is happening here? It is from infinity to minus infinity and passing the x-axis at pi by 2, pi by 2. But whereas in the tan x curve, it passes from origin pi and 2 pi. That's the difference. Okay, guys. So that's the cortex graph. And then let's look at cosecant. So cosecant, we know it will be outside of minus 1 and 1. So let's look at 0, 0, pi by 2, and then pi, 3 pi by 2, and then now what is the angle here? 0, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. So it's taken in the clockwise. The first table is in the clockwise. Okay. What is cosecant x is 1 by sin x, the reciprocal of sin. So what is sin 0? Sin 0 is 0. So that means the reciprocal is 1 by 0, which should be, right? So at origin, it is starting at infinity. Okay. And then what is pi by 2? So sin 90 is 1. That means this is also 1. Then what is sin pi, right? That's in the second quadrant. Sin pi is in the second quadrant. It is still positive. So it is plus infinity. And then 3 pi by 2. 3 pi by 2 is what? In the fourth quadrant. That is the negative y-axis. So value should be minus 1, right? And then 2 pi. Pi is again infinity. Right? Now, how this graph looks like, right? First, let's draw on the positive side. That is 0 to 0. At 0, it is infinity. Somewhere it's starting here at infinity. And then at pi by 2, it is at 1, right? Then again at pi, it is somewhere at infinity. So it's like a parabola. It's like a parabola. It's like inverted U. Like this, guys. You understood? So this is between 0 and pi. Now, what happens between pi and 2 pi? For pi and 2 pi, for pi it is infinity, and for 3 pi by 2 it is minus 1, and for 2 pi it is again infinity. That means it's like inverted U, inverted parabola comes in the fourth quadrant. Understood, guys? And similarly, let's look at the actual graph, guys. See the graph, right? So let's look at the clockwise angles. So 0 is infinity and minus 90. So minus 90 is where? In the fourth quadrant. fourth quadrant, what is the y coordinate? It is minus, right? And pi is in the third quadrant, the y coordinate. What guys? Then here, 3 pi by 2. 3 pi by 2 is a positive value. This is 1. This is infinity. Now let's start. Between 0 and minus pi. So 0 is what? Infinity. And minus pi by 2 is minus 1, guys. Minus 1. And then pi is again infinity. That means, so at origin, it is infinity. And at pi, it is infinity. So that's an between 0 and minus pi. Then what happens between minus pi and 2 pi? So minus pi is infinity and minus 3 pi by 2, 1 minus 2 pi is again infinity. That means again, you come here with one. So this is the cosecant, right? So if you see here, guys, what is happening is 1, is 1, this is 1, and this is minus 1. So this graph is going outside of 1 and minus 1. That means infinity to 1. And here, minus, right, guys? Or you can write this as minus 1 comma. You can write this as minus 1 to minus infinity. Okay, so that's the range. Now, look at the secant graph. Secant graph will also be similar, but I think only the displacement position will change. Now, secant is what? 1 by cos x. So 0, pi by 2, and then what is this? Pi, 3 pi by 2, and pi. Now, here 0, pi by 2, then minus pi, minus 3 pi by 2, and minus 2 pi. All right. So what is cos 0? Cos 0 is 1. Then secant 0 is also 1. And then this is a anti-clockwise angle, guys. So 90. 90 is in the first and second quadrant. So the x quadrant is 0, right? So, oh, hold on, guys. So this should be infinity, right? So cos 90 is 0. That means this is infinity. And then 180. So 180 is what? The x quadrant, which is minus 1. And then 3 pi by 2. 3 pi by 2 is again infinity. And then 2 pi. 2 pi is what? 360 degrees, which is a positive value. So it's 1. Now, let's look at how the graph is. At 0, it is 1, guys. At 0 angle, it is 1. And then at pi by 2, it is infinity. So somewhere here. That means the graph is like this. Okay. And then at pi, between pi by 2 and pi, what is happening? At pi by 2, it is infinity. And pi, it is minus 1. Pi it is minus 1. And then at 3 pi by 2, again it is infinity. That means I can draw something like this. It's an inverted U. Okay. And again, what is happening between 3 pi by 2 and 2 pi? It is 3 pi by 2 is infinity and 2 pi is 1. So that means this is again like same as the cosec x. Okay. And now let's look at the minus values. So this is 1. And 90 degrees minus values. So here it is infinity and pi. Pi is again, what is cos 180? Cos 180 is cos x, right? So that is minus 1. So we should get minus 1 here. And then infinity and 1. The same values. Because cos of minus x is cos x. Now, so let's look between pi and minus pi by 2. So this is from 1 to infinity, guys. So that means This is a U-shaped curve. Between minus pi by 2 and pi by 2, it is a parabola, right? And now let's look at minus pi. Minus pi, what is the value, guys? Minus 1. So at pi by 2, it is infinity, and at 3 pi by 2 also infinity. That means it's an inverted parabola or inverted U. Understood? And now between minus 3 pi by 2 and 2 pi, minus 3 pi by 2 is infinity and 2 pi is 1. So that means it should be something like this here. It should be something like this. This is the secant x curve. So let's look at the original curve, which is drawn here, right? So here in the diagram, it is on the left side, it is only drawn up to minus pi, but I draw up to minus 2 pi, right? So between minus 2 pi and 2 pi, here also the range is from infinity to 1, right? And here it is minus 1 to minus infinity, right? The domain is same. Domain is minus 2 pi to 2 pi. All right, guys. So this is how you can draw the uh, graphs for all the 6 trigonometric functions. Okay, hope you guys understood. So let's take a quick summary, like all the graphs, right? So this is the sin x curve, guys. So the sin x curve is like a moving snake, right? It's like a moving snake. And here, this is called the amplitude, guys. So yeah, I missed to tell this. Amplitude. So what is amplitude? Amplitude is the height of the curve. What is the height of the curve here? The amplitude of the sine curve is 1, right? So same with the cos x. The amplitude of cos x is also 1 because the range, the highest value. So here 1. Now this is the cos x curve, guys. So both sin x and cos x curves are similar. The only difference is there is a shift of pi by 2. So here, why I'm saying there's a shift of pi by 2 means here at 0, sin x passes through the origin, but here it is at 1, right? So next, y equal to tan x. Y equal to tan x is from, the range is from infinity to minus infinity, and it passes through the origin. And at, and this pattern repeats for every 180 degrees. Between minus pi by 2 to pi by 2, it is like minus infinity to infinity. Now, then cot x exactly opposite to the tan x. So it is also like 180-degree intervals. But it is from, if tan x is like this, the cot x is like this because it's reciprocal and it doesn't pass through the origin. And then cosecant x and secant x. Cosecant x and secant x are similar curves. Like sin x, cos x are similar curves with a shift of pi by 2. And tan x and cot x are also similar curves, but reciprocal. So it will be opposite. Opposite. It's like a mirror, right? If you see tan x graph in a mirror, you will get a cot x graph. And similarly, the cosec and secant, right? Cosec is between minus, apart from minus 1 and 1, and it's like a parabola, u and not u's, but there is a displacement of, there's a shift of pi by 2 here, like how sin x and cos x differ by pi by 2. Here also these differ by pi by 2. So at origin, if cosecant x is infinity, at origin secant x is, right, it differs by pi by 2, really. Uh, This is the summary, guys. Here, the amplitude is there for only cos x and sin x. Because it is a, the range is within the node, minus 1 and 1. But for all these other tan x, cot x, cosecant, and secant, the range is from infinity to infinity. So we cannot measure the amplitude. All right, guys. So that's about the trigonometry. Now, let's quickly review uh, this work, right? So if sin x, cos x, tan x, cosec, secant, cot, that's what we learn. Now in the board exams, they go the application. That's what they text in the board exam. Now, what happens if they give a different app, right? Like in place of x, if they assign 2x or 3x, right? How to do? Let's look at it. 0, pi by 2, take the same angles, right? Pi by 2, pi, 3 pi by 2, and 2 pi. So what is sine values, guys? We know sine 0 is 0, it's 1. Sine pi. Sine pi is also 0. 3 pi by 2 is -1, and pi is again. Now, what is sine 2x? 2 times of the angle. So, sine 2 into 0 is 0. So, that is sine 2 into pi by 2. 2 into 90. That is pi. Sine pi, right? So, what is sine pi value? Sine pi value is also 0. Following, guys? Sine pi is also 10. What is sine 2 pi? Sine 2 pi is 10. What is sine 3 pi by 2? Right? So sine 3 pi by 2 is what? 2 into 3 pi by 2 is sine 3 pi. So what is sine 3 pi? Pi plus 180, right? So pi means 180 degrees, 360 degrees, and another. So it will also be a zero value. And then what is sine 4 pi? That will also be a zero value. Yeah, I have the graph for that. What is happening here, right? So sine 2x, right? Sine 2x is also 2x is also a graph. We need to find that pi by 2, right? So pi by 2 means we need to check for pi by 4 value, right? So at every, like, okay, first let's put the values, right? So at 0, it's 0, and then at 2 pi means pi value, right? Yeah. Pi is 0, and at 2 pi, right? 2x means the pi values we have to take, right? Now, what is that pi by 2? Pi by 2, what we will get if this is pi by 2, then what we will get is 1. When we will get if the angle is 45, because 2 into 45 is 1. So we need to take mid value also for this. So that means at 45 degrees, this is 1. At 180 degrees, this is 0. And then at 3 pi, I mean, at 95, 90, and 45 is 135. 135 is -1. So what happens is at 45 degrees, it becomes then following right, guys. At 3 pi by 2. What is 3 pi by 2? Then again, basically what happens here is sine 2x means it goes very fast. That means the, uh, the range reduces, not range. So for every 90 degree, it covers the loop, right? Similarly, here, these values, right? Let's take 0, right? This is 0, sine 2x is also 0. Now here we will take pi by 4 values, guys. What is minus pi by 4? Is minus pi by 4 means 45, right? What is 45 minus 1 by, yeah, minus 1 by root 2. And 90 degrees, it will be -1, right? Pi by 4, then we'll take pi by 2. So pi by 2 is 1 here. If I multiply with 2, 2 into pi by 2 is 0, right? That's how we need to take. And then we will take pi by 2 plus pi by 4. Pi by 2 plus pi by 4 is 3 pi by 4. That is 135 degrees, guys. So this angle is where in the second quadrant. So that will be 1/2, right? And here this will be 1, and then pi. So the pi value is 0, and 2 pi value is also 0. So these values we can take. Now, what is between 0 and pi by 4? At pi by 4, it is becoming maximum, and pi by 2 is becoming following, and then here again become 1 like this. So if I take for remaining values also like this. So it is a sine curve, exact sine curve, but there the interval was from 0 to 0, it was 180 degrees. But here from 0 to 0, it is 90 degrees. It's 2 times of that. So it will be a sine curve with general sine curve. If I want to draw, the general sine curve was at 90, it was becoming 1, right? So the frequency gets increased here. So here at 45 degrees, it is reaching max, and then at 90, it is coming down to 0 again. So that's how you can draw for 2x or 3x. Okay. Hope you understood, guys. Now let's look at 3 cos, right? Okay. Let's take 0 and pi by 2, pi, 3 pi by 2, and 2 pi. Now, what is cos 0, guys? 1. Cos 90, guys? Cos 90 is 0. And then what is cos pi? Pi is 180, right? So 180 is the negative side, the second quadrant. So minus 1. And 3 pi by 2. 3 pi by 2 is also 0. 2 pi is again 1. 3 times. So here, like if you get cos 2x, sin 2x, you need to multiply. But here, 3 into cos x, you just need to multiply the value that we got. Multiply these values in this row with 3. 3 into 1 is 3, 3 into 0, 0, minus 3, 0, 3. So here, the curve interval will not change, but the amplitude will change here. Let's see how. So at 0, right? At 0, it is what, guys? Yeah, we are drawing the graph for 3 cos x, right? At 0, it is 3. So at 0, it is 3. And at 90, pi by 2, it is 0. Guys, and at pi, it is minus 3. At pi, it is minus 3. And at 3 pi by 2 is again 0. And at 2 pi, it is 3. So what is happening here, guys? So the curve is same as the cos x curve, but what is happening here is the amplitude. The height of the curve is changing. The height of the curve, the general cos x curve, the height is 1. Here, the height is 3. And similarly, let's look for 0, minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Now, what is cos x, guys? Yeah, this is 1, and minus 90. Minus 90, this is 0 in fourth quadrant, and minus pi is into the third quadrant, that is minus value, so minus 1. Then fourth quadrant, sorry, the second quadrant, so that's 0, and this is 1. The same values we will get. Now, because cos of minus x is cos x, then this is also 3, 0, 3, 0, 3. Now, let's draw this. So at 0, it is 3, and at minus pi by 2, it is 0. At minus pi, it is minus 3, and at 3 pi by 2, it is 0, and 3. Now, you understood, guys? So this is cos x. Here, the height of the curve or the amplitude is becoming what? 3. In the regular y equal to cos x, the amplitude is 1. So let's look at the how. Yeah, this is how we get the exact graph. Understood, guys? So here, if you multiply sin x or cos x with a cos x, 2 cos x, 5 cos x, right? And if you do in the previous example, if we do this one, what happens? Sine 2x, cos 2x. Here, frequency reduces. Okay. All right, guys. So yeah, that's what I wanted to do. In the board exams, these type of problems you'll get y equal to sine 2x, sine 3x, cos 2x, or 3 cos x, 5 cos x, like, right? So you just need to extend the knowledge that you have learned drawing the graphs. All right, guys. So that's all for today's session. Hope you understood the topic. In case if you have any further questions, you can reach me using my Urban Pro.